We've been obsessed about aliens for a long time, but it really feels like in the last few years, the search is getting a lot more serious. We both have practical tools like the James Webb Space Telescope, which allow us to search the atmospheres of other worlds. And then you've also got sort of an increased attention because of UAPs. You've got NASA, you've got the military, you've got the government looking into, are aliens visiting us here on Earth? And, there's no evidence that they are, but it's an interesting question. And are we alone in the universe? It really is a scientific question that deserves an answer. And we will keep hunting for it until we find it. So my guest today is Dr. Adam Frank. I've interviewed him many times in the past. He's an author, he's a scientist, and a person who is sort of right at the heart of searching for technosignatures in the universe, trying to find evidence of alien civilizations beyond Earth. He's got a new book called The Little Book of Aliens, and it really sort of covers the history of the search for aliens, various ideas that people have, and what the future might hold for our search for other life of any kind in the universe. So enjoy this interview with Dr. Adam Frank. Adam, when did we first wonder about aliens? Like, when did that occur to us?
Yeah, a long time ago. It's really one of the oldest questions you can see humanity sort of arguing about. And in fact, formally, you can see the Greeks yelling at each other. Aristotle had the opinion that the Earth was unique, particularly because he thought the Earth was the center of the universe. But then Democritus and the atomists held the position that the universe was made out of atoms and atoms were universal. Therefore, there should be other planets with other life on them. So literally, people have been arguing about this for 2,500 years. Occasionally, they've burnt each other at the stake over it. So it's been an issue that can get heated, no pun intended, or maybe a pun's intended. But it's an ancient human question.
But like our modern conception of other planets around other stars with life forms existing, like, when did that start to sort of creep into our collective consciousness, do you think?
Yeah, that's a good question. And that, it's funny, after my, sort of 30 years of, doing astronomy and sort of keeping the question of alien life on other planets in the back of my head, it's only recently that I started to really, with these last two books, particularly the new book, obviously The Little Book of Aliens, that I started to really look at the history of it. And I think it's around the 17th century, after Newton, and people started to get a better idea of how to do the physics of stars, at least, just conceiving them as other suns, even if we didn't really know what was powering the sun. You see, like in the 16th century, there is a bunch of books that are written, often with the title of the Many Worlds Hypothesis or something along those lines, where you see people actually thinking about stars and planets going around them and the possibility of life on them. So it's really 1600s, 1700s, is you get a birth of new, what we might call alien optimism, that there is the possibility of life out there. So that maintains until you get to evolution, the theory of evolution, and then people start asking, well, is life really going to form on these other worlds? And what's remarkable is actually by the early 1900s, because astronomers thought that planets were going to be difficult to form, people were pretty pessimistic about the possibility of life in the universe.
Do people fundamentally misunderstand the Fermi paradox? Like what Fermi was really getting at?
I think, well, there's, as I talk about in the book, there's really two different Fermi paradoxes, and they get deployed in different ways. The first Fermi paradox is the one I think he actually meant when he was, talking over lunch and suddenly, blurted out, where are they? And what Fermi realized that day was that even if you had a spacefaring race that was moving at 1/10 of the speed of light, could travel between the stars at 1/10 of the speed of light, that they would be able to cover the entire galaxy, basically settle every world in the galaxy in a very short time scale relative to the history of the galaxy. So that's what we call the direct Fermi paradox. But the one that people get confused about is what I call the indirect Fermi paradox. People have this idea that, like, every night astronomers are pointing their radio telescopes at the stars and searching for life, and that we've never found any, that we've done some kind of extensive search for signals of aliens, and we've never found them. And that is completely wrong. And the reason it's completely wrong is so mundane, is that there's never been any money to do those searches. So very little SETI searching has been done. So that's really the problem with that one. So people think that we've searched and we haven't looked, and the reality is we've never really searched.
Do you think that Fermi understood how feasible it would be for an advanced civilization to settle the galaxy?
You know, what's interesting about the Fermi paradox is probably Fermi never thought about it again after that lunch conversation. Yeah, because he was so smart. Right. It was really Hart in 1975. So this idea of the Fermi paradox kind of floated around. People, it was very much in the gray literature, as we call it. But then it was Hart who in the 1975 who wrote a paper that sort of formalized the Fermi paradox as a paradox. And Hart used it, the logic of Hart's reasoning, which I describe in the book, goes basically that, look, there's so many stars, there should be lots of intelligent life. If even one of those species was able to propagate, was able to travel through the universe, then they should have covered the entire the entire galaxy by now. And we don't see anybody here. Therefore, there's no other intelligent life. Like that was the way he based his logic. So he certainly thought that it was possible to colonize, to settle other worlds. And then there's this idea of the von Neumann probes that, maybe it's machines that are doing this. It doesn't have to be biological critters. It could be just automated probes that are hopping from one solar system to the other, consuming resources to build the next version of themselves, and then hopping to the next solar system. So I think other people thought about this more generally. And the Fermi paradox, the direct Fermi paradox does have some issues about it. And we've written some papers. I think you and I even talked about it one time, some of the paper that we did. But it's really the indirect Fermi paradox that I think is the one that people misunderstand most of all, because we're just about ready to really search for life. Like now there's finally funding and there's a community, and we have, it's not SETI anymore. I don't even really want to use that term SETI anymore, because to me that refers to one part of what I would call technosignature science.
That Hart paper lives rent-free in my brain, for sure.
Right.
That is really those arguments are devastating.
Yeah.
And so, like, if there was a counterfactual and the aliens were inhabiting the cosmos, what would that look like? What would we see for a bustling cosmos?
We would probably see. That's a really interesting question that we can ask. Like, if there were if there really was life in many places, then would we expect to already be colonized? Would we expect to have? Should we find ancient monuments or something ancient? Or should they be here right now? Which, of course, if you're into UFOs, you say they are here right now. So just a couple points on that. So as we discussed, that paper that we wrote a few years back, where we simulated the settlement of the galaxy, we found that there's one question of how long it takes to settle the solar system, but then there's the question of the steady state. Like once you've settled the whole, or not the solar system, the galaxy. Once you've settled the galaxy, then what happens? If every settlement has a finite lifetime, which, settlements, nothing lasts forever, right? Then you can end up with big holes. You can have regions die off and they can remain unsettled for millions, hundreds of millions of years. That's what we found. So it's possible that we're living in a bubble. That one way out of the Fermi paradox is we're living in one of those unsettled bubbles, and eventually they'll come through again. There might have been one here billions of years ago, and as we showed in that paper with Gavin Schmidt, there's no way to tell. If there was a civilization, a technological civilization here on Earth a billion years ago that lasted 10,000, 100,000 years, all evidence would be gone. So that's an important point when thinking about the direct Fermi paradox. So to your question, what would it look like? That's an interesting, let's assume that we live in one of these bubbles. So that's why there's no one here right now. Would we be able to tell that the galaxy was bustling? You might try and look for their communication signals. What you're going to want to look for are inadvertent indications that they exist. So, maybe they're using radio to communicate, and maybe we'd be able to pick up their signals. Maybe they're using tight beam laser, because that's actually probably the best way to really communicate across large distances, even across solar systems. Because radio, if you're beaming it out widely, you need so much power to be able to still be heard a long way away. So we might be able to pick up those kinds of things. We might be able to see their drives, the propulsion, whatever they're using. If they're using these giant phased laser arrays to push solar panel or light sails around, we might be able to see that. But it's also possible that with the technology we have right now, that we're not sensitive enough to detect that. So it's possible they could be everywhere except here, but we don't yet have the capacity to find it. But of course, we are developing that technology so quickly that in 10, 20, 30 years, maybe we would be able to detect a drive plume.
But it's been theorized that the universe was habitable from about, say, 6 billion years ago. And so advanced civilizations have had a 6.5 billion year head start on us. So if there is a vibrant multiple civilizations of aliens in the cosmos, and they are reaching, they've had billions of years of technological progress to turn what is a wilderness of the cosmos into, I guess the cosmos equivalent of a city, whatever's the end state of settlement, what would that look like?
Yeah. God, that's cool. The question though, there's a bunch of sub questions there that we take on in my research group. We take on quite a bit, and in the book I really try and unpack, which is, can you even have a contiguous civilization for billions of years, right? So we sort of have this assumption that civilizations, become advanced, and then somehow they're eternal. And that part I really wonder about, that whether or not you can hold a single culture, right? Whatever civilization you're going to have is going to have some kind of culture, whatever version of that. And for billions of years, would it be one civilization, or would it be a series that rise and fall, a la Isaac Asimov's Foundation?
Or think about Baghdad, right? Like how many people have set up in that region and built city after city on the bones of the previous city. Right.
And that's exactly what I wonder about, whether or not, a fully settled galaxy, something like, in Foundation, where Trantor is the imperial capital, then yes, you would expect all of these worlds to have settlements on them, or at least the ones that are economically viable, the ones that you can do something with. You probably are not going to settle on worlds where there's nothing for you to do. Life, the most important requirement of life is to keep on living. So these worlds have to be useful to them in what ways? And so this also raises the question of, would they even, if a civilization lasts millions and it's advanced, would it even be biological anymore, right? Would they even, and if they're not biological, if they become, silicon-based, or even if not, they could become silicon-based either by downloading their consciousness into that. I'm not sure that's possible. Or somebody creates AI and that's what takes over. Would they even need planets anymore? So that's what's so interesting about this question. And again, this is the kind of stuff I try and deal with in the book, so people can see that when you start really thinking about this, you got to push your imagination past, science fiction is great because science fiction can really help us imagine the alternatives. But it's almost like you have to formalize the ideas in science fiction and systematize them to be able to evaluate which ones are more probable than others and what the physics consequences, the physics biology consequences are of the different alternatives. So the idea that for example, that they're only between the stars, they're basically silicon and they're only traveling between the stars. Would we have any indication that they existed if they never landed planet-side? So these are the kind of questions we try and ask in my research group and the kinds of things I'm trying to explain to people in the book.
If you take a car into a place like New York City, that is a part of planet Earth that has been utterly reshaped to meet the needs of the civilization that lives there. What does that look like?
Yeah, now that's interesting. So this idea, this leads us to technosignatures, right? That a world that has been reshaped by its species,
or not just a world, like everything, anything,
a galaxy, an entire
like
galaxy.
whole galaxy. What would a galaxy modified for the needs of the advanced civilization? You'd think would be something we could see. What would we see?
Well, we might see Dyson spheres. It might be that like some very large number of those stars have been harvested, right? That they have had solar, some kind of solar collector around them, either Dyson spheres or Dyson swarms. And for your listeners who don't know, a Dyson sphere was this idea that Freeman Dyson came up with in 1960, very early on, when he recognized that as a civilization progresses, it's going to need more energy, and the best energy source that you had, natural energy source that you have, is a star. So perhaps advanced civilizations cover their stars, or at least build spheres around these stars, the interior of which is covered with solar collectors of some form. So the idea of a civilization covering, harvesting all of its stars' energy, you can extrapolate to the next level and imagine a civilization that has access to all of its galaxy's stars. So in that case, you might see a galaxy that is luminous in infrared light, without starlight, without the visible starlight, because these Dyson swarms are all, the second law of thermodynamics tells us you can't harvest energy without some consequence, and that would be waste heat, and which would mean glowing in the infrared. So that would be a possible consequence. And people like Jason Wright and others have been looking for Dyson spheres, the infrared signatures of Dyson spheres.
It's interesting, like with Jason's latest paper, he kind of dismantled the original expectations of that. The thought is, well, it makes sense to build a sphere that is at the orbit of the Earth, but actually that's not the most energy efficient, mass efficient way to do it. In fact, you want to build something small, close to the star, be efficient with your materials. And another idea going around was whether you need to have shells that are at different distances harvesting the waste heat from each other, and his calculations were no. So just one tight sphere harvesting as much energy before the thing actually starts to melt, and you're getting the maximum amount of energy out of that star with the minimum amount of matter invested. And I think about this in my imagination, like if an advanced civilization, maybe it's AI, wanted to optimize their reachable universe into whatever form gave them the most value they could possibly do, what would that look like? Right? Because then you're moving stars. You are tearing stars apart. You are feeding stars to black holes to get the most efficient outcome. You are using computing substrate at whatever is the right distance. You are moving planets to pack them into habitable zones. Like, that seems dramatic in the way that flying to space on Earth, you look down at night and you're like, okay, I see city lights.
Right.
It's hard to miss.
Yeah, and that's the thing. That level of astro engineering is extraordinary, and how the degree to which any civilization reaches that. But I don't think necessarily that we have to go there, or because one of the things that we have to do in the field is, as I said, try and systematize what the trajectories of civilizations are. And that means you have to sort of lay out all the possibilities of technology and technological development, and then what the consequences of those would be, as well as some sense of the social forms that would that might mitigate that, because it's not clear that everybody would want to do that. That would, that we have this sense, we live in this very interesting brief moment of human history where we've had this amazing acceleration, right? That we've gone from the Wright brothers flying in 1903 to a helicopter on Mars in 2023. But most of human history was a much flatter development of technology, and you can even see that now. The fastest somebody could go, an average person could go in 1960 was about 500 miles an hour on a jet plane. The fastest an average person can go right now is about 500 miles on a jet plane. Technology can definitely stall. So I think we have to be careful about this idea that, it's going to go on forever, that there's infinite amounts of technological progress which will give us infinite amount of godlike powers. I think it's possible, and that's one trajectory. But another trajectory is that things stall out and you have relatively stable forms of technology that are used to, astroengineer or populate planets, or that planets have to enter into some kind of sustainable state with their biospheres. So all of those possibilities are the kinds of things that we have to understand when we try and imagine both the trajectories of civilizations, but also what it is we're looking for, because we're so close now to being able to look for it. I mean, we can now. JWST is right on the hairy edge of being able to detect, say, chlorofluorocarbons, an industrial chemical in, a TRAPPIST, on one of those TRAPPIST planets.
But I mean, isn't this kind of cognitive dissonance? Because, like, on the one hand, let's say the aliens have had a 6 billion year head start on us. And then on the other hand, we clearly don't see the evidence of them reshaping the universe at the vastest scale. And then you say, well, but maybe people don't want to do that. But then you say, well, but maybe the grabby aliens always want to. And you go back and forth. And it feels to me like the universe that we see is whatever the universe can be at maximum. That we've reached our max. We've had 6 billion years. We've reached our maximalist state right now. We've seen whatever's possible. In the same way that we've seen essentially the maximum amount of the spread of life on Earth. Life's everywhere. It's in the bottom of 10-kilometer boreholes. It's trapped under the ice in Antarctica. It's floating 30 kilometers above the surface of the Earth. It's in every extreme environment that's possible. Life has found a way to get in there and exploit whatever it can.
Right.
And so, like, on the one hand, we say, well, we don't see that, so maybe, they just haven't gotten around to it and whatever. And then on the other hand, people say, well, we sure can. Like, there's no reason why we can't. Let's build our warp drives and let's get on it. But it feels like whatever is possible for us in the universe has already been tried. And that's our future.
Yeah, I don't think that doesn't resonate with me a lot. Just because also the big assumption there is civilizations last contiguously for billions of years. That's the thing I'm probably most suspicious of. I think that it's not clear to me that you can get civilizations lasting for such long times, and that there is this infinite expansion of technologies, that there may really, we already know, like with the speed of light, right? The speed, it's entirely possible that there's no warp drive. Like, sorry, warp drives are just not possible. We'd all like them to be possible, but they're just not. And you think about that, think about what that actually implies. Let's just take that. If warp drives if you're stuck with the speed of light, then it's actually becomes, and your biology is such that you don't last for thousands of years, then suddenly even small-scale interstellar civilizations become very difficult. And so this is something I really unpacked in the book because I found it really fascinating. How do you have diplomacy when it takes 100 years? If it's just you and a star that's 100 light years away, you have 3 stars. Let's say you have 3 planetary systems 100 light years away. Every interaction takes 200 years. You send them a message like, hey, how you doing? 200 years later, good. So it's like the idea of a civilization that could marshal its forces, that could bind itself together to carry out activities together, becomes really difficult to imagine how that might happen. So that's why the reason why that doesn't resonate with me so much is the idea that you're asking for, though it's entirely possible, right? Because we could talk about the ways it would be possible, but is that I really question what it means to be a long-lived civilization. And I'm not sure you get one long-lived civilization. And whether or not you can really have truly interstellar civilization. It's possible everybody's a one-off, a planet one-off,
But you look at a place like London, before it was London, it was Londinium, and before that it was a settlement. Like, it's a useful place. People have been improving it as a location, and then various civilizations have been using that improved location over time. So you may not get one contiguous civilization, but you are at least getting an overall improvement of the environment, or a changing of the environment by these people. So, I mean, for me, it feels like there must be some fundamental reason that we haven't discovered yet why expanding beyond our star system makes sense. And like the arguments that people make about, like, in the future, you're going to turn all of Jupiter into computronium, and you're going to,
Right.
And then in fact, it's the lag that kills you. Like as soon as you have to spend a second of lag, that's, then the alien supercomputers are going to be losing on their online gaming, and they're not going to stand for that. And so they're just not going to want to build any kind of compute substrate that has ping times that are just too long. They're not willing to leave the system because like who wants the lag? That's terrible. That feels to me like a reasonable explanation that everyone will always realize that it's actually best to stay home.
Yeah, and I think that's and I can see that happening on different levels. It's best to stay home because really leaving home is super expensive and very difficult. And you lose contact with them almost immediately, right? You send a Century ship to Alpha Centauri or whatever, and they start a civilization, and then the civilizations drift. They become very different from each other. So it's not like you're, the United Colonies or the United Federation of Planets. Each one becomes its own separate thing and has its own separate. So I think I consider that to be a real possibility that. It's just so, interstellar travel may just be really difficult. So you may have, the whole galaxy may be full of civilizations, but they're not interstellar civilizations. They're interplanetary. Like you look at our own future, right? Should we make it through climate change and all the other things that we have to deal with? I can imagine every nook and cranny of the solar system being inhabited, right? We wrote this paper a little while ago asking about could you take asteroids and spin them up and then live on the inside of them? So, I think that's entirely feasible. And that's something that may be possible in a few hundred years. But so you can imagine that solar systems get completely inhabited. And there's lots of ways to find evidence, technosignatures from solar system engineering. There's an idea that we've been exploring called service worlds. That if you want to harvest a lot of energy, don't cover half the Earth with solar panels. Cover the moon with solar panels because you're not using the moon, right? Or that's where you put your dangerous industry and such. So there may every system that has a technological civilization, go look at the planets or the moons that those are the ones to focus on. That's where the industry is going to be. So it's easier for me to conceive of lots and lots of solar systems that are each inhabited and then a galactic empire.
We've already found the best planet in the universe for us.
Earth? You mean that Earth is max? Yeah, well, no, I think there's probably, I would imagine, people talk about these sort of super Earths or super habitability. So I'm not sure that we found the best one for us, right?
Yes.
And we just recently wrote a paper, Amadeo Balbi and I just wrote a paper about oxygen, that maybe, for technology, you really need an oxygen-rich atmosphere because without it, you're not going to be able to have combustion. And without combustion, how do you get
that was a really interesting paper. I love that kind of thing where someone just like, well, what about this? And you're like, oh, yeah. The octopuses are going to have a hard time starting fire underwater.
That's right, right. Water worlds. So that's I can imagine a universe that is full of life, that is teeming with life, where, every liquid moon, every Europa has intelligent squids doing intelligent squid things, but that we don't have, that the interstellar travel may be the really hard part. And that's isolated and that's difficult, but that life is popping up everywhere.
Yeah, they're banging the rocks together and just nothing, no spark. So now you referenced this earlier on. You said, people are thinking that maybe the people who believe in UFOs think that aliens are coming to us and that Fermi paradox solved, aliens are coming here all the time. And there has been a real resurgence lately in this. Do you think there's any there?
Currently, there's no there in the terms of actually having data you could use, right? As Mike Turner, one of the great particle physicists, once said to me, with a really good scientific project, you put a quarter in and you get $1 out. And the problem with UFOs is you put a quarter in and the quarter's gone, right? So what we have lots of stories, often by people who, you have no reason to think that they're lying, or you have fuzzy blob pictures. But the problem is none of those can you build a scientific theory that you can then scaffold the next question, right? In science, you don't just answer a question and be like, well, we're done. That, almost immediately, your answer to that question becomes the technology that you use to answer the next question. And up to now, UFOs, has been a mix of narratives, people seeing things, fuzzy blob pictures, ridiculous conspiracy theories. Roswell in particular, I have a whole chapter on Roswell. I went and I read the Roswell books. And after a while, pretty quickly, I was like, this is a mess, right? And then hoaxes, pure on hoaxes. And Roswell has a few of those. That very famous 1990s show, Alien Autopsy. I don't know if do you remember that one? It was Riker, Commander Riker was the narrator, and I was so disappointed in him for that. And that turned out to be a total hoax, right? The whole thing was filmed in some guy's living room in Brixton, England. So, up to now, I don't think there's anything there. The narratives about the military has, alien spacecraft in their garages. We've heard this forever, right? So, in the book, I talk about one of the first reports that came out on UFOs in the 50s, the leader of that, the military leader of that, I think he was a captain. Afterwards, he published a book. After he retired, he published a book and said there was this report, this top secret report called the Estimate of the Situation, which claimed that that UFOs were alien spacecraft. No one's ever found the report. Like after digging and digging, the report. So it's like, and the problem with this is that if you're a scientist, it just looks like a morass of speculation and stories that you can't do anything with. But the difference that's happening now is, I think thanks to the pilots, I think those pilots are they're reporting what they saw. That there's the kind of interest in it that may now lead to some real scientific investigation, and we'll see where that leads. Right? That investigation has to be agnostic. And we will see where it leads. And I personally, if there was good, solid data that linked that had a link between the data and the claim that these things are behaving in ways that no human technology can reproduce, I'm open to changing my mind. That's the beauty of science, is it shows you how to change your mind. But at this point, it's still a mess, and there is nothing that out there that would warrant the conclusion that we're being visited by extraterrestrials right now.
With all of this interest, both from governments as well as the military, as well as NASA, perhaps, begrudgingly being brought into this, there's going to have to be, to get more information, more data, there's going to have to be increased amounts of transparency, but also potentially new methods of searching. This starts to overlap into some of the other thinking that you've had over the years, which is here's some ways to look for stuff in the solar system. Here's some ways to look for ancient civilizations on Earth. So what do you think would be a productive way to get some serious evidence about the presence of alien civilizations here in the solar system?
Yeah, I think that's a great question. And I have a whole chapter in the book that sort of details, okay, you want to do science on UAPs, here's what you have to do. And the important thing for that is you're not going to be looking to answer the question, are there aliens on Earth? You're going to be looking to collect data about UAPs. You're just looking to collect data and then analyze that data in a way that gives you the ability to determine the performance characteristics, right? And then from that, you're going to have to then try and draw conclusions about, is this human technology? Is this not human technology? So there's really three options. You can build ground-based sensors looking up. You can put satellites that look down, and you can also mount things on aircraft. And maybe you want to do all three. But the important thing, and that people really, especially in the UFO community, often don't understand, is that unless you have fully characterized the instruments, you don't know what you're getting, right? And this is the problem with the radars, the military radars, is that unless I know when was the last time that radar was refurbished, I need the entire history of the thing. I need the machine itself, and I need to have built it myself, or else I just can't trust it. And this is exactly what we do in astronomy, right? The James Webb Space Telescope, we understand everything about its behavior. We understand how it responds to infrared light when the telescope is at 20 degrees, and we understand how it responds to infrared light when it's at 80 degrees, right? We know everything about it, because that's the only way that we can link the data, we can be sure of the data, and that we can then link the data to a claim or a conclusion. And UFOs are no different. It's not like UFOs get a pass on this. And so we'll need to build those kinds of instruments and deploy them. And I think that's probably going to be coming soon. I think, the public is interested in this. And so, we'll do that work. We may learn some really interesting things, even if we don't learn anything about life in the universe. But that's the only really way to do it. And the important thing to notice is that let's say we did all that and we found that there were certain objects that were making right-hand turns at Mach 500, right? Something that really, a human-powered technology can't do. Well, what do you do next? Like, that would be stunning. And what do you do next? Well, the only thing you can do next is more science, right? Because it wouldn't tell you what it was. It wouldn't tell you where it was from. It would just tell you, like, wow, this thing is behaving in a way that human technology can't produce. So, like I said, that's the example of good science, right? You put a quarter in and now $1 comes out. You did this, you found something extraordinary, which would be mind-blowing, but then, you don't stop there because you still wouldn't know what it was. And, then you have to ask, do I try and shoot one down? Do I try and capture it? Or do I just keep trying to do, now I develop the next level of sensors that can, tell me the next level of detail about it.
When you talk about life in the universe, and one of the possibilities is that we are alone. But for most people, that is like emotionally, they literally just can't wrap their heads around that. How do you think it might be reasonable to think that we are actually alone? Or why do you think people get that response?
Well, I think it's entirely, I'm an alien optimist. And I want to also note, for me, it's just as profound if we found a biosphere, a microbial biosphere on an alien world, as if we find a civilization. Like, I don't really care, because either way, it's profound. Because the thing is that life is so different from non-life. Living systems are so entirely different that we just want to know whether or not life itself is an accident, that it only happened here and that's it, right? Because that would be a stunning possibility and kind of weird and depressing in a lot of ways. So if we just found one example of life elsewhere, even if it was just microbial, that would actually, if we find one example, then there's probably other examples. It means we're not an accident, and there's probably other examples, even if they're, in other galaxies or whatever. But and because life is so creative, then to me, all bets are off. That, who knows, somewhere life has done amazing things. But let's say even that's not possible. Let's say that we really are an accident. That would be stunning. That would really be, and I think I would have a hard time wrapping my mind around that. If we searched and searched, obviously, you're not going to be able to conclude that in 30 years. But let's say we had 500 years of searching and we simply never found any evidence of any other biospheres, of any other activity, any other life anywhere else. On the one hand, it would mean that we would really need to cherish. I think ethically, it would change everything. Then, the killing of, on some level, everybody needs to become a vegetarian from that point onward, right? Because that means life is so rare and so sacred and so important that we have to do everything we possibly can to maintain it. And then, in some sense, interstellar travel or the settlement of other worlds, I think, becomes imperative to spread life. If we're the only life there is, I take it as life is a good. Life is important. I would say that, everybody, the conclusions, everybody has to be a vegetarian, and we absolutely have to start settling the stars.
Yeah, I say trees are better than rocks, right?
Yeah.
And that if we are truly alone, then boy, did we mess up.
Did we mess up?
If we didn't get off this planet and ensure that life could spread across the universe.
Right. Right. You know, the way I've always looked at when people talk about settling Mars or settling the solar system, you know, some people have this idea that it's unethical to, you know, to settle Mars. And I really disagree with that. I mean, obviously, if there's life on Mars, then we have to be super careful. But, you know, it's not us settling Mars. It's not human beings settling Mars. It's the biosphere. It's Earth biosphere. We're the agent of the biosphere that's going to be sending a green tendril out to Mars to expand it. So, you know, the whole history, as you pointed out, the whole history of Earth's biosphere is just covering everywhere, getting any nook and cranny on the planet life has spread to. And we should see the rest of the planets as that's exactly, you know, we're just the agents of the biosphere for that.
There have been proposed dozens of ways to search for technosignatures, and you've been involved in many of the meetings that have helped figure out those ideas. There's a master list kicking around that I really want to get my hands on, but apparently it's not ready yet.
Yes, it's not ready yet, yeah. But it will be soon, I think.
Please send it to me when it's ready.
Right.
What do you think best bang for the buck? If you had to go all in on one technique, where would you invest? If you had to push all the chips in, what would be the single technique that you think could give us the best bang for the buck?
Well, I really think it's atmospheric technosignatures. It's things associated with looking at planets, right? Because the great thing about atmospheric tech, and you know, atmospheric is one particular find, but I would say planetary, right? Looking for, in that first famous meeting in 2018, what I called metabolic technosignatures. Technosignatures associated with a civilization just going about its business, right? Because in the early days of SETI, because of the requirements of radio messaging or radio technology, what you really required was somebody sending you a message, somebody pointing at you with a big radio telescope and pumping lots of energy into a message or a beacon, maybe it's not even a message, you know, aimed at somebody. And that never really made a whole lot of sense to me. It was the only thing they could do, so it was brilliant and it was provocative work. But I think it's much better just to go find aliens doing what aliens are doing. And so that requires looking at planets, and that's what we can do now. We can look at alien planets, which is where aliens are probably going to live, and just look for them going about their civilizationing business. So, go ahead.
Do they know we're here?
They probably could. Certainly, if you were looking at if you had telescopes of the kind that we're getting soon, like even with JWST, you would know that Earth has had a biosphere for billions of years. Earth has been recognizable as a habitable, as an inhabited planet for a long, long time. And for the last 100 years or so, if you're within 100 light years, you can see that we've been changing the planet. We've been adding technosignatures to the planet.
And there are tens of thousands of stars within 100 light years of us. Like it's.
I think that number is pretty good. Yeah, I'd have to go back
I think it's it's 60,000. I forget the number exactly.
So there are definitely there's worlds that have that are within the range to see. Like look, the city lights. The backside of the planet is lighting up. Oh, okay.
If we get an email from the aliens, should we open it?
That isn't it. We should open it up, but I'm not sure we should respond. Right? I mean,
should we even open it?
Like why? Because you think there's a virus in it or something that
what's the easiest way to deal with a potential rival? Send them instructions for a machine that will destroy their planet.
Will destroy them. Yeah. Right? No, I think we should open it up. We should definitely. I don't think there's no way we could not open it up. Right? We're just too curious.
Yeah, that's what they're counting on.
We'd have to be real careful about what we did with it. Yeah, I wouldn't sure. It's like, getting an email, right? But what's attached to it, right? That's the great. Do we open the attachment?
Yes.
That may be,
yeah. Do we open the attachment?
Yeah. This goes to that whole the dark forest hypothesis, which I take seriously. I think I'm not a big fan of METI for that reason. I think we should really be careful about, because it's one thing to say yes, we are visible. But there's lots of planets in this, or lots of stars in the sky. It's not clear that anybody's looking for us directly, or that's different from sending a giant, or putting up a giant flashlight, or sending up a flare to announce your presence, where you really tell everybody, hey, look, hey, everyone, we're here. I think that's something that we should be careful about, because we often have this idea that aliens, they're peaceful, they're wonderful, but that's anybody's guess. I mean, it's not clear. intelligence may be associated with being a predator, right? That's certainly for us. It's been, it's the predatory species that are the most intelligent often. So, yeah, I think one should be careful. There could be wolves among the stars.
A hippopotamus isn't a predator. It will mess you up.
That's a point too. Yeah, it's great. Large grazing civilizations might also have their own problems that we need to deal with.
Yeah, I think about that. Do you think they'll look like us?
No. And that's one of the things. So that's why, especially with the, in the book and writing the book, I was really also aiming at people in the UFO community, because I get why people, I get why, whether you're in the UFO community or just really interested, I get it. Look, my whole life is about, studying life in the universe. It's super exciting. But, you always have to engage in the science, because the science has a lot to tell you, right? And so this idea that the grays, the little humanoid looking aliens, when you look at evolution, and we know a lot about evolution, it's really, really hard to imagine that on another planet you would get all the accidents, because, evolution is a battle between convergence and contingency. Convergence says, look, if there's air, if you're living on a planet with an atmosphere, you're going to get some version of wings. Wings are a great way of, evolution will stumble on wings, but it doesn't tell you what the wings are going to look like or how many wings or what version. We're just talking about surfaces that air can flow over. So the idea that you're going to get, so that's convergence, and contingency are all the accidents, all just the, a snail is sliding along and then a rock rolls over it and it dies, and that's the end of that lineage. So the idea that you're going to get all the accidents that you need to reproduce a head, on shoulders, with arms, 2 arms and 2 legs, it's just not going to happen. Or it's so improbable that you would get this kind of configuration. The problem with that view is it doesn't do nature service. Look at all the insane varieties of life we have, where everybody comes from the same last common ancestor. If you start off with an entirely different lineage of life, it's just not going to look like us. So I would put a lot of money down that not only are we the only humans, we're the only humanoids. And we should expect to be, when we actually find aliens and get to, meet them, we should expect to be surprised and grossed out, probably.
But also, we'll get it. I think we see that alien and we go, oh, I get it, right? That we'll see them and it'll make sense. We'll know, they have a way of seeing the electromagnetic spectrum. They have a way of encountering sound waves. They have a way of interacting with their environment, manipulating their environment. And we also know, if we know where they came from, then how they function will be apparent to us. We'll go oh, I get it. I never imagined it, but I get it.
That's exactly what it is. Definitely, life will be constrained by the laws of physics and chemistry and the logic of Darwinian evolution, right? I think those are all going to be universal. But the path, you already just look on Earth and you look at the paths that can take, there's an infinite amount of variety. Nature is so much more creative than we are. And
it's kind of obsessed with crabs, though.
It does. Right. A lot of walking sideways, right? And a lot of tentacles too.
Yeah.
But it's been said that if you even if with Earth, if you went back a few billion years and rewound the tape and reran it, Earth's evolution, there's not a single creature, single species alive today that would be here. It would have headed off in a different direction. There'd be fins, there'd be wings, there'd be legs, but it wouldn't look anything like what we have.
So Adam, what are you obsessed with right now?
Starfield, the video game.
Have you played No Man's Sky?
No, I haven't. Actually, I played it when it first came out, when it was not that
so
great.
much better now. So there's and it has that similar scratches that same itch.
Elite Dangerous I played for a long time, but I'm really digging it. It took me a while to get into Starfield, but I'm really digging it. But I don't think that's the question you're asking.
I find that a perfectly satisfying answer. But no, I was interested. So I want a sneak preview of what paper you're working on next is my sneaky way of asking this question.
Yeah. So on one whole field I've been taking on or working in is the idea of just what is life? What separates living things from non-living things? So we got a grant recently from the Templeton Foundation to study what's called semantic information. So let's look at life from, this is Sarah Walker's perspective.
I saw a paper just yesterday about this.
Yes,
2 years ago?
because our paper just came out, and then today I have something in. I wrote a piece on it for Big Think.
Okay.
So the idea that you want to look at life not as a thing but as a process, and information is what really separates this. The idea is what really separates living from non-living systems is the use of information. So black holes have information, but they don't use it. They don't process it for any of their own ends.
Right,
so
they hoard it.
So we published our first paper, just came out yesterday.
Okay, that's the one that I saw. I didn't notice your name on it, but I didn't look carefully.
Yeah. So that was that's a really exciting. It's just a first step. We're just sussing out this idea of we're using a paper by Kolchewski and Wolpert from 2018 where they formulated the idea of a theory of semantic information, and now we're starting to apply it. So that I'm really interested in. We're also working on a paper to ask. This is a great question about technosignatures. How long will the lunar lander be visible on the moon's surface? In other words, if somebody came 1 billion years ago and dropped maybe a big monolith or something on the moon, how long till just micrometeorites, it's called gardening, that's what they call it, gardening, would just wear it away? So for solar system SETI, we're just doing those calculations now. How long would something last? So that's another project that I'm working on. We got a long list.
Do you think that your Silurian hypothesis about Earth, the math is different on the moon, where we don't have the same kinds of weathering that's happening on the moon? Because I've heard people make the proposal that the best place for us to do a core sample is on the moon. Like dig down through several hundred meters of regolith, bring it all back home, and slowly you'll get a record of every solar flare, every gamma ray burst, every supernova, and in theory every melted monolith.
Right. That is exactly right. I mean, right.
Yeah.
The Earth, the weathering, you have a few million years before pretty much the whole surface is reworked. But on the moon, stuff's going to sit there forever. So that's why nobody had ever done the calculation. People have done, there's lots of calculations about weathering of the regolith, of the lunar soil, but nobody said, okay, put a plate there, put a metal plate, 3 inches thick, and ask how long is that going to be there before it's sort of broken apart so finely that you couldn't see it. Because people have proposed we have all these high resolution maps of the moon. Let's do machine learning and see if can the machine find anything unusual? The machine has no problem finding the lander.
Right.
You can give it to a computer and it'll instantly identify, hey, that's weird. So that's what we're trying to find out. So that's a project that will be coming along.
Yeah, and that idea that searching for anomalies, like someone did something similar with, they fed the entire dark energy survey database to a machine learning algorithm and said, identify all the galaxies that you can, but also tell us everything you couldn't identify. Yeah. And those are interesting. And there is boundless to be new things, new kinds of objects that people have never proposed before out there in the universe. It's just a matter of it's needles in the haystack. So, the book again.
Excuse me?
The book again, your book?
The book.
Do you have a copy? Oh, there we go.
The Little Book of Aliens on sale, October 24th. It's, everything you need to know about everything there is to know right now about life in the universe. So I hope people will be interested in buying it, including UFOs and UAPs, which, I also deal with, trying to look at how science will look at them.
Wonderful. Well, thanks, Adam, for taking the time to chat with me today, and good luck with the book, and good luck with finding aliens.
Great. Thank you. I'll let you know if we find any.
Perfect. Now, I'm going to talk a little bit more about sort of conclusions that I got from this conversation with Adam. But first, I'd like to thank our patrons. Thanks to David Richards, Mark Anstis, Antonio Lofilara, Justin Cable, Vlad Shiplin, George, Andrew M. Gross, Jeremy Mattern, Josh Schultz, and Jordan Young, who support us at the Master of the Universe level, and all of our other supporters on Patreon. I think we're at a great time where we've had all of this speculation about whether or not there are aliens in the universe, and it's been an argument. And for a while, it was sort of considered something that you just don't propose to NASA to actually go look for aliens. But in 2018, the dam broke, and people started to accept or recognize SETI and just the search for technosignatures in the universe as a legitimate form of scientific study. And there are dozens of ideas that have been proposed. We could see time being used on the James Webb Space Telescope to search for biosignatures and technosignatures in the atmospheres of other planetary systems. And so we are now moving into this era where what was before kind of a philosophical question, the kind of conversation you'd have over beers with your buddies, to a proper scientific question. And of course, it's one of the most fundamental questions that we can possibly ask. Are we alone in the universe? Either way that question gets answered, it is important for us. Now, I've talked to Adam Frank several times in the past about this and other topics. And so I thought, if you want to sort of continue the conversation with Adam, more recently, we talked about that idea that he mentioned about turning asteroids into space habitats, that you could take an asteroid, spin it up, and live on the inside of this torus that you've got. It's a fascinating concept and could give us a practical way to live in the solar system. The other interview that I did with him was a few years ago, and sort of talking about that idea of how civilizations might spread across the Milky Way when you consider civilization starting and stopping. Could we be living in a gap in the spread of a galaxy-wide empire? And it's sort of an interesting conversation. So enjoy both of those interviews here on the channel. All right, thanks for watching, and we'll see you next time.